In this video, we're going to do new equations, but this time we're going to use our logarithm properties to solve this type of equation. So first thing we're looking at here is a basic log equation. And at the moment, really, there's only one trick I can use, and that's to rewrite the logarithm into exponential form. So first of all, since this doesn't have a base, it's the common log, it's base 10. So to rewrite it in exponential form, I'm going to take 10, and I'm going to raise it to the 3, and then I'm going to set it equal to 2x minus 6. So 10 raised to the 3 equals 2x minus 6. Okay, but 10 to the 3, that is 1,000. And if I want to solve for x, I'm going to add 6 to both sides. I'm going to skip showing the step. Then I'm going to divide by 2. So I'm going to get x equals 503. Now, you do want to kind of get yourself into the habit of checking your answers. The reason is, in particular, with logarithms, we have a limited domain. We can only plug in positive numbers. So we want to make sure that if I plug the number back into the original equation, it doesn't give us something, really weird. And it doesn't. It gives us a nice positive number. We could actually work out the equation. In fact, let's take a second and show that. So if I plug my answer in, this would be 2 times 503 minus 6. And then 2 times 503 is 1,006. Minus 6 is 1,000. And now I have log of 1,000. So I'm going to rewrite 1,000 so it has the same base, 10 to the 3. So that equals 3, which is what the equation said. See? Boom, boom, done. All right. Now, we don't have to go through all of that work. What I'm really going to do is just check that it doesn't give me a negative when I plug it in. That's what I have to look out for. Okay. So let me make a note, check to make sure we don't plug a negative. Wow, that's a really sad version of the word negative. Negative into the log. All right, great. Keeping that in mind, let's move on. Okay, so this next example, we actually have 2 logarithms, which we can combine together into one logarithm using the difference property. So this can be rewritten as a division. So this is log of 50x plus 25 divided by x. And that's all equal to 2. Okay, but what's nice about what I have here is I actually can use my changing the logarithm into exponential form like I did on the last problem. So again, this is log base 10. So this is going to be 10 to the 2 raised to all of this. So 10 to the 2, oops. And that's going to equal 50x plus 25 over x. Okay, 10 to the 2 is 100. And now I could cancel that denominator by multiplying both sides by x. So those will boop, cancel. And I am left with 100x equals 50x plus 25. And now I can just solve this like normal. So minus 50x. That gives me 50x equals 25 divided by 50. So x is 1/2. And I should make sure, like I said a second ago, that if I plug it back in to the original, here, I'm going to zoom out a little just so I can kind of see my work here. Plugging 1/2 back into the original isn't going to give me a negative, and it won't. It'll just take half of 50, which is 25, and you're able to combine it. And then plugging it into the other logarithm, I'm going to find the log of just 1/2, no problem, because I can take the log of 1/2. I just can't take the log of a negative. Okay, so there we go. Let's look at another example. Now this one is different. And the reason this one's different is we actually have logarithms on both sides of the equation. Believe it or not, that actually makes our life a little bit easier. So what we're going to do is on the left side, I'm going to combine them into one logarithm. And since it's an addition, that means that this will become the natural log. Oops, sorry. My computer did not want to let me write. Okay, there we go. So this will become the natural log of x plus 2 times x plus 1. And that's equal to the natural log of 4x plus 14. Okay, now, here's what's beautiful. Because I have the natural log of something equals the natural log of something, really what we're saying is that these two things that we're taking the natural log of, those things must be equal. So we can drop the natural log. So this just becomes x plus 2 times x plus 1 equals 4x plus 15. I'm sorry, 14. And now I can work it out using all the techniques we've learned before. So let me go ahead and FOIL this. So this is going to be boop, 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 boop. All right. X squared plus x plus 2x plus 2. So x squared plus 3x plus 2. And then I'm going to go ahead and, because there's an x squared, I'm going to get everything equal to 0 and see if maybe I could factor. So I'm going to subtract the 4x and the 14. So this is going to become negative x, and then 2 minus 14 is negative 12. All right. This does factor into x minus 4, x plus 3, which gives me two solutions, x equals 4 and x equals negative 3. Okay. And now I have to make sure that neither of these are going to give me negatives. And I can see negative 3 is a problem. In the first one alone, negative 3 is a problem. So I'm not going to include that as a solution. Only 4 is a solution. It will plug in and give me nice positive numbers. I could work it out, make sure it actually does equal, but I'm not going to stress about that. We're just going to go ahead and disregard the negative 3. All right. Let's look at this one. In 2008, the population of Kenya was approximately 38.8 million and was growing by 2.64% each year, while Sudan was 41.3 million and growing by 2.24% each year. If they continue, when will the population of Kenya match that of Sudan? Okay, so since we're talking about population growth, we're going to kind of pull back to when we did the growth equations, and we're going to do exponential equations for both of these. So let's look at Kenya's. So Kenya's equation is going to be, so our initial value is 38.8, and then we have a growth rate of 0.0264, and that'll be raised to the t. So 38.8, 1.0264 to the t. That's the equation that represents Kenya's growth rate. So remember, I'm just using the equation that was a times 1 plus r to the t. That equation is the one I'm using. Probably should have wrote that down first. Whatever. Sudan is 41.3, oops, times 1 plus 0.0224 to the t. And then let's just add those two numbers. And there we go. Okay, so what we're interested in figuring out is when Kenya is going to catch up to Sudan. In other words, when their populations are equal. So let's set these two equations equal to each other. Now, kind of gross, and you are going to want to get your calculator because we're going to use it a lot. But we are going to have to end up using logarithms at some point, because my variable that I need to solve for, the t, is exponents. And I'm going to eventually have to take the logarithm to get rid of those, bring those exponents down. Before I do that, I kind of want to deal with the fact that I have these numbers in front. Actually, you know what? I'm not going to. I'm just going to take the logarithm of both sides. I'm going to have to use the log properties, but that's what I'm going to do. Take the log of both sides. And you can use any log. I'm just going to use the natural log just because it's quicker to write. So I'm going to take the natural log of both sides. Here, let me put it in brackets. 38.8 times this. And 41.3 times this. All right. Now, using the log properties, I'm going to take and break up these multiplications and rewrite them as additions. Wow, my brain just did not want to say the word addition. So that's natural log of 38.8 plus the natural log of 1.0264 to the t equals the natural log of 41.3 plus natural log of 1.0224 to the t. Okay, now both of these are just decimals. So what I'm going to do is, for the moment, I'm going to ignore the fact that there's a lot of gross writing and just know that those are just numbers that I can plug into the calculator. And I'm going to go ahead and solve for t. The way I'm going to do that is I'm going to bring those t's down from the exponents, which was the whole point of doing these natural logs, or any log for that matter. I want to make sure that that's a plus sign and it looks distinctive from the t. Natural log of 1.0264, natural log of 41.3 plus t times the natural log of 1.0224. Okay, so now I'm going to get the t's to one side and everything else to the other. So first thing I'm going to do is I'm going to move this natural log of 38.8 over here. And then I'm going to move this t to the left side, to the other t. Now I can't combine these. These are not like terms. Okay. So here, let me boop and boop. And here's what I'm left with. Okay, on the left side, I have t natural log of 1.0264 minus t natural log of 1.0224 equals the natural log of 41.3 minus the natural log of 38.8. Now, on the left side, I'm going to factor out t. That's going to get me down to 1t. And I have the natural log of 1.0264 minus the natural log of 1.0224. If I wanted to, I could bring these two together as a division, just so I don't have to write it out. But I don't have to. I can leave it as a subtraction and plug that into the calculator. I think it'll actually end up being easier to plug a division into the calculator. So I am going to go ahead and write it more condensed. I think that might be easier to plug into the calculator. And for that reason, then what's in this bracket here, I could also rewrite as the natural log of 1.0264. That's such a sad one. I'm sorry. Let me see if I can fix it there. Okay. Over 1.0224. And I'm trying to squeeze it in a little too small because I did a bad parentheses. So let me fix that. 0.224. Okay, great. And this has the t in the front equals this. Okay, so I'm going to solve for t by dividing both sides by this natural log. 264, 1.0224 into this. Okay, so this is what I'm going to plug into the calculator. These two natural logs of two different divisions. Okay, and what I'm going to be left with is my answer. So I'm going to take a second. I'm going to plug this in the calculator. Natural log of 41.3 divided by 38.8, all divided by the natural log of 1.0264 divided by 1.0224. And I come up with 15.991, which I guess we could just say is about 16 years. I think that's a reasonable thing to say. In about 16 years, the two countries will have the same population.